Let's prove this very interesting formula for repeatedly differentiating e to the x times cosine of x. The way that we're going to do that is to realize that e to the x times cosine of x is the real part of e to the 1 plus I times x. And so if I were to differentiate e to the 1 plus I times x and just take the real part, that would be the derivative of e to the x times cosine x. So let's take a look at this. What's the derivative of e to the 1 plus I times x? Well, the constant just pops out, so 1 plus I times e to the 1 plus I times x. What happens if I take a second derivative? If I take a second derivative, then an extra 1 plus I pops down. So the second derivative would have 1 plus I squared. And by the same logic, if I were to take n derivatives, this would be equal to 1 plus I to the nth power times e to the 1 plus I x. Okay, now let's figure out the real and imaginary parts of the right-hand side. 1 plus I is equal to the square root of 2 times the cosine of pi over 4 plus I sine pi over 4. And quickly, the reason that that's true is because if we draw the complex plane, 1 plus I would be here, 1 over, 1 up, and the distance from the origin would be square root of 2, while the reference angle would be pi over 4. So that's converting 1 plus I into trigonometric form. Okay, so if I take 1 plus I to the nth power, that would be equal to square root of 2 to the nth power times the cosine of n pi x n pi over 4 plus I sine n pi over 4. And then this is getting multiplied by 1 times the cosine. Sorry, I misstated myself. This is getting multiplied by e to the x times cosine pi over ix, so cosine x, plus I sine x. And that's converting e to the 1 plus ix into trigonometric form. So therefore, by the rules for multiplying complex numbers, what I have here is 2 to the n over 2, 2 to the 1 half to the n, so half times n gives me the exponent, times e to the x, and then the angles add. So I have cosine of x plus n pi over 4 plus I sine x plus n pi over 4. And therefore, the real part of this nth derivative the real part of that nth derivative is going to be the real part of the right-hand side. Everything except the sine term. And as we've established, the real part of this exponential function is simply e to the x times cosine of x. So that's equal to 2 to the n over 2 e to the x times cosine of x plus n pi over 4. And so that's the proof. So we have a fairly surprising formula for the nth derivative of this thing. You'd think that using the product rule you'd have a fairly complex expression, but it's actually a fairly simple expression thanks to de Moivre's theorem.